Welcome to Algebra 1, Unit 6, Lessons 1 and 2. Here are a few pairs of positive numbers whose sum is 50. Find the product of each pair of numbers. Now, sum is when you add the numbers together. Product is when you multiply the numbers together. So 1 times 49 is 49. 2 times 48 is 96. And 10 times 40 is 400. Number 2. Find a pair of numbers that have a sum of 50 and will produce the largest possible product. So for number 2, this is 25 and 25. When we multiply them together, we get 625. Number 3. Explain how you determined which pair of numbers have the largest product. What I want you to notice is that the first number is getting larger. 1, 2, 10. And the second number is getting smaller by the same amounts. As the first number gets larger, the second number gets smaller. And the product gets larger. After we reach the midway point, 25 times 25, we just begin repeating the same numbers in their opposite order, and their products begin to decline. So the halfway point is going to be the largest product, because if we multiply 24 times 26, then we go to 25 times 25, we'll hit that peak, because the very next thing we would do is flip and multiply 26 times 24 and go back down again. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Here are some lengths and widths of a rectangle whose perimeter is 20 meters. Complete the table. What do you notice about the areas? So we have length is 1, width is 9. The perimeter is 2 times length and width. So if we add 1 length and 1 width, it should be half of the perimeter, so that would be 10. So to fill in the rest of the width, when length is 5, width is 5. When length is 7, width is 3. And when length is 9, width is 1. Now the area is found by multiplying length times width. So 1 times 9 is 9. 3 times 7 is 21. 5 times 5 is 25. 7 times 3 is 21. And 9 times 1 is 9. What do you notice about the areas? The area increases until the halfway point. Then it decreases. Number 2. Without calculating, predict whether the area of the rectangle will be greater or less than 25 square meters if the length is 5.25 meters. Well, we see that the area goes up until it hits 5.5. So, if we increased to 5.25, now we're between these numbers right here, and the area was going down from 25 to 21. So it would be less than 25 square meters. Number 3. On the coordinate plane, plot the points for length and area from your table. So when length was 1, area was 9. When length was 3, area was 21. When length was 5, area was 25. When length was 7, area was 21. And when length was 9, area was 9. Do the values change in a linear way? No. They are not linear. It does not form a straight line that goes in the same direction forever. Do they change in an exponential way? No. They are not exponential. They do not increase quicker, and they do not decrease quicker. They increase, then they decrease. If you have any questions about how I solved this practice problem, Please use class time to ask for further clarification. The table shows the relationship between x and y, the side lengths of a rectangle, and the area of the rectangle. Number 1, explain why the relationship between the side lengths is linear. So what we want to look at is that x increases by 2, increases by 2, and increases by 2. At the same time, y increases by 4, increases by 4, and increases by 4. The relationship is linear because every time x increases by 2, y increases by adding 4. That makes this a linear relationship. Number 2, explain why the relationship between x and the area is neither linear nor exponential. Well, if we look at the changes in the area, you could add 24, then add 40, and add 56. We're not adding the same amount every time. If I'm looking for a common factor, I could say times 4, but then the next time it's times 2 point something, and the next time it's times 0 point something. It's less than 1, or less than 2, so it's times 1 point something. So the relationship is not linear because the same amount is not added. The relationship is not exponential because the factor is not the same each time. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Which statement best describes the relationship between a rectangle's side length and area as represented by the graph. Choice A. As the side length increases by 1, the area increases and then decreases by an equal amount. We can clearly see we do not have a straight line going up and a straight line coming down, so A is not correct. Choice B. As the side length increases by 1, the area increases and then decreases by an equal factor. We can clearly see this does not have exponential growth up and then exponential decay down. So B is not correct. D, as the side length increases by 1, the area does not change. We can clearly see we do not have a horizontal line of points, so D is not correct. Choice C, as the side length increases by 1, the area does not increase or decrease by an equal amount. That is true. It increases and decreases by more towards the beginning and the end, and it increases and decreases by less in the middle. If you have any questions about how I answered this practice problem, please use class time to ask for more clarification. How many small squares are in step 10? What we need to do is find the pattern. So what you can notice is in step 1, I have 1, and then I have a square that is 1 by 1. In step 2, I have 2, and then I have a square that is 2 by 2. And in step 3, I have 3, and then I have a square that is 3 by 3. So every time we have the step number, we'll call n, plus n squared. So now if we want step 10, we would have 10 plus 10 squared. Do the exponent first. 10 squared is 10 times 10, which is 100, and 10 plus 100 is 110. So our correct answer is choice D, 110. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Here are two patterns of dots. Number 1, how many dots will there be in step 4 of each pattern? For pattern A, we start out with no dots. In step 1, we have one row of 4 dots. In step 2, we have 2 rows of 4 dots. And in step 3, we have 3 rows of 4 dots. So in each instance, we have 4 dots times the number of rows that we have a step. So 4 times 0 is 0, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. That means in step 4, we have 4 times 4, which is 16 dots. Pattern B. We can see that we start out with 2 dots on step 0. Then we have 2 dots and 1 in step 1. We have 2 dots and 4 in step 2. And we have 2 dots and 9 on step 3. If you can't see it, let me draw it in here. Step 2 has a square of 2. Step 3 has a square of 3. And step 1 has a square of 1. So we start out with 2, and then we add the step number squared. So for step 4, we're going to have 2 plus 4 squared, which is 2 plus 16 equals 18 dots in step 4. Number 2. Which pattern shows a quadratic relationship between the step number and the number of dots? That would be pattern B. Because it can be found by squaring the step number and adding 2. Pattern A is actually linear because we are adding 4 every time. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Here are descriptions for how 2 dot patterns are growing. Pattern A. Step 2 has 10 dots. It grows by 3 dots at each additional step. Pattern B. The total number of dots can be expressed by 2n squared plus 1, where n is the step number. For each pattern, draw a diagram of step 0 to step 3. So first we'll do pattern A. We have step 0, step 1, step 2 we know has 10 dots. And step 3, we know that we are adding 3 dots each step. So if we had 10 in step 2, we should have 13 in step 3. Going the opposite direction to find step 1, we would need to subtract 3. So going from 10 to 7. And again, to go from step 1 to step 0, we're going to subtract 3, and we just have 4 dots. So this is what pattern A would look like. Now for pattern B. We have step 0. 0 squared is 0. 2 times 0 is 0. And 0 plus 1 is 1. So step 0 has 1 dot. Step 1. 1 squared is 1. 2 times 1 is 2. And 2 plus 1 is 3. Step 2. 2 squared is 4. 2 times 4 is 8. And 8 plus 1 is 9. And finally, step 3. 3 squared is 9. 2 times 9 is 18. And 18 plus 1 is 19. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Each expression represents the total number of dots in a pattern where n represents the step number. Select all the expressions that represent a quadratic relationship between the step number and the total number of dots. If you get stuck, consider sketching the first few steps of each pattern, as described by the expression. So, if we want a quadratic relationship, the step number needs to be squared. In choice A, the step number is squared, so that is correct. In B, the step number is multiplied by 2, that is not correct. In C, the step number is multiplied by the step number, and that is the definition of squaring. In D, the step number is added to the step number, so that's incorrect. Choice E, the step number has 2 added to it. That's incorrect. And choice F, the step number is divided by 2. That is incorrect. So A and C are the correct answers. If you have any questions about how I solved any of the problems in this worksheet packet, please use class time to ask for further clarification.